In this lecture, I'm going to talk about Rbac. In the previous theory lesson, I explained that Rbac is still in alpha for 1.3, but in the meantime, there are a few newer Kubernetes versions that came out and Rbac is now stable. It is also now enabled by default if you download and install the latest version of kops. So I will now cover Rbac and then I will do a demo to create a user on kops and then configure Rbac for that user. Let's talk about authorization. After authentication, authorization controls what the user can do. Where does the user have access to? The access controls are implemented on an API level using the kube API server. When an API request comes in, for example, when you enter kubectl get nodes, it will be checked to see whether you have access to execute this command. There are multiple authorization modules available. You can use node, a special purpose authorization mode that authorizes API requests made by kubelets. Attribute-based access control. Access rights are controlled by policies that combine attributes. For example, the user Alice can do anything in the namespace marketing. Rbac does not allow very granular permission control, so it's not very interesting to use. Rbac is a better choice. So then we have Rbac, role-based access control, regulates access using roles, allows admins to dynamically configure permission policies. And this is what I will use in the demo. And you also have webhooks, sends authorization requests to an external REST interface. It's an interesting option if you want to write your own authorization server. You can then parse the incoming payload, which is JSON, and reply with the access granted or access denied. So we are going to use Rbac of those options, which is now enabled by default on most clusters. To enable an authorization mode, you need to pass authorization mode to the API server as startup. For example, to enable Rbac, you pass authorization mode equals Rbac. Most tools now provision a cluster with Rbac enabled by default, like kops and kubeadm. For Minikube, it will become default at some point. There's an open issue for this. In the meantime, to get this authorization mode passed, you can use this following parameter: minikube start extra config API server authorization mode equals to Rbac, and then your minikube cluster will also be running Rbac. Once enabled, you can add Rbac resources using kubectl to grant the permissions. You first describe them in YAML format, then you apply them to the cluster. First, you define a role, and then you can assign users and groups to that role. You can create roles limited to a namespace, or you can create roles where the access applies to all namespaces. The object role is a single namespace, and the cluster role is cluster-wide. The object role binding is a single namespace, and the object cluster role binding is cluster-wide. So every time you prefix cluster, it's going to be cluster-wide. So here's an example of an Rbac role granting read access to pods and secrets within the default namespace. So this is of kind role, not cluster role. So this is specific to one namespace. Here we define a namespace default. You can then define the main API group. So if you leave it empty, it's the main API group. Resources are pods and secrets, and you can get, watch, and list them. Once you define a role, then you can use role binding to say, I have a user Bob, and that user Bob needs to get access to the role pod reader. Still in the namespace default. If you want to do the same thing, but then cluster-wide, you just change kind from role to cluster role, and then you don't specify the namespace. Then you have a cluster role that is cluster-wide, that is over all the namespaces. And then instead of role binding, you use cluster role binding. Everything is still the same, except that here the namespace attribute is not here anymore. So that's it, and then in the next demo I will show you how to add a user in kops and give that user permissions.